This is the instructional video for day 1 of section 13.2. In this video, we will explore the product rule, the quotient rule, and power to a power rule of exponents. It will be very helpful for you to have your notebook handy, and it will also be helpful if you're watching this instructional video with a partner. Before we move into the rules of exponents, let's take a moment to stop and think about some of the rules that we already know. In fact, you already knew these rules before walking in the doors of our 8th grade math lab. So our first problem is x times x. So whenever I'm multiplying and I'm doing x times x, my answer, and I think everybody knows, is x squared. My next example is x plus x. So when I'm combining like terms by adding, I'm going to change my coefficient. So my answer here is 2x. These are important rules to distinguish. So when I'm multiplying with I change my exponents. When I'm adding, I change my coefficient. So if you ever get stumped or stuck or confused on any of the rules of exponents, come back to these two simple problems that, like I said, you already knew how to complete before entering 8th grade. Take a moment to jot down these two examples in your notebook, leaving space between them to show your work, and write product rule at the top. Go ahead and pause the video so you have enough time to jot down those two problems. Okay, so question number 1, we have 3x squared times 4x. The product rule for exponents says that you can use the commutative property of multiplication to group the factors that have the same base. So basically what I'm doing here is I can think of this problem instead of as multiplying two things, really, because I'm multiplying in between both of these sets of parentheses, so I can think about it like this. 3 times x squared times 4 times x. And the product rule says that I can use a commutative property to group factors that, like I said before, have the same base. So what that means is 3 and 4 are coefficients. They're the same, so I can go ahead and multiply those. 3 times 4 is 12. Then, from our last example that we did in our quick review, we have to multiply x to the second power times x to the first power. Notice that I said first power even though there wasn't anything written here. So if you want to take a moment to put an exponent of 1 there, if you think that's going to help you, go ahead. And in the last slide, we said that when we multiply our exponents, we're really going to add them. So my final answer here is 12x, I have to add my exponents, to the power of 3. So that's my final answer. When I'm multiplying with exponents, I have to add my exponents. All right, take a second to look at the next example. In the next example, I'm going to do the same thing. I've got 3 different bases. I have my coefficients, I have my a variables, and then I have my b. So my final answer is going to have 3 components to it. So I'm going to go ahead and multiply 5 times 2. That's going to give me 10. I'm going to multiply a squared times a to the 5th. So when I'm multiplying, I add my exponents. So that's going to give me a to the power of 7. And if you notice, I don't have another b. I've got this b, but nothing over here. So when that happens, then I just bring my b to the power of 3 down. So my final answer is 10, a to the 7th, b to the 3rd. At this point, I'd like you to pause the instructional video, look back at the last few examples that we did, and the product rule, the things that I explained in the video. Discuss with your partner how to use the product rule. Once you're done discussing with your partner, in your notebook, write how to use the rule in your own words. Be very specific when you're writing down how to use the product rule. Make sure you reference how to calculate your coefficients and how to calculate the exponents of the variables in your example. Pause the video, do steps 1, 2, and 3, and resume the video when you've got your notes jotted down in your notebook. Take a moment in your notebook to jot down power to a power rule and jot down these two examples. Pause the video if you need a moment. Okay, power to a power rule, excuse me. What this says is I'm taking a power, so in this case, the first problem, x squared, and I'm raising it to the power of 3. So to do that, I'm going to show you a little bit more work than you really are going to have to do when you're writing this in your notebook for me. But take a moment just to jot it down so you have this example written out. X squared to the power of 3 means I'm going to take x squared and multiply it by itself 3 times. So I'm going to multiply this out the long way to show you why and how this rule works. So what I have here is x squared times itself 3 times. So I have x squared times x squared times x squared. Now using my rule, my product rule that I just talked about in the last slide, I know that when you are multiplying, you can add your exponents. So 2 plus 2 plus 2, that's going to give me x to the power of 6. All right, hopefully you see a little pattern here. Let's look at the next example. I've got y to the 4th squared. So I'm going to take a minute to write y to the 4th times itself twice. So again, I'm going to refer back to my product rule, and when I'm multiplying with exponents, I add them. So my final answer here is going to be y to the power of 8. That's supposed to be an 8 there. Okay, so hopefully you saw some sort of pattern happening here. If I have x squared cubed, my final answer is going to give me x to the power of 6. If I have y to the 4th power squared, I'm going to get y to the 8th. So hopefully you can see that a shortcut when I'm taking a power to a power is to multiply my exponents. So 2 times 3 is 6, 4 times 2 is going to give me 8. So a shortcut when you're using a power to a power rule, instead of showing all of this work, is to multiply your exponents. And again, this is only going to work because I've got the same base here. Take a moment to pause the instructional video and again discuss with your partner how to use the power to a power rule. Once you're done discussing with your partner, in your notebook, write how to use the power to a power rule in your own words. That's really important. And again, just like last time, make sure in your notebook you're describing how to use and to calculate the coefficients and the exponents of the variables in the examples. Before we chat about the quotient rule, which is the last rule in this instructional video, let's take a moment just to review a concept here. Now, this is called a quotient, and we're going to talk about the quotient rule in just a second. But this is a quotient because I'm dividing. So one thing that I want you to consider when you're doing division, such as x to the 5th times x squared, is to think of this problem very simply. So x to the 5th, I can write it like this: x times x times x times x times one more x. So I have 5 x's on the top and 2 on the bottom. So I'm thinking of the quotient rule. I want you to think about taking your factors like x to the 5th and writing them out. Same with x squared. Now, what you might remember from way back when you learned about prime factorization in elementary school is that when you have the same factors and you're dividing, you can cross them out. So I have 5 factors on the top and 2 on the bottom. So I can cross off as many common factors as I have. And this is going to leave me with x times x times x, or from the product rule that we learned about first in the instructional video, we could simplify this by writing it as x to the power of 3. Because when I'm multiplying, I add my exponents. And I'm just putting ones here to remind me that this is 1 plus 1 plus 1, which is going to give me x to the 3rd power. Now, just like in the last slide that we talked about, maybe you're seeing hopefully you're seeing some sort of a pattern. X to the 5th divided by x squared, a shortcut to go from here to the answer and skipping all this work is subtracting your exponents. So if I do 5 minus 2, I'm going to get 3. And a helpful way for me to remember this is to think about this as x to the 5th, like this, and x squared like this. And I can cross off those common factors, leaving me with only 3 x's. Take a moment in your notebook to jot down a quotient rule and to write down these 2 examples. Press pause on your instructional video so you have enough time to do that. Okay, when we're using the quotient rule, they're not always going to be as simply put as the first review example that we just went through. So, a couple of things that you have to remember when you're looking at the first problem is I am dividing 9 divided by 3. And I'm going to think of this as m cubed divided by m, or m to the power of 1, and n to the 5th divided by n to the 7th. So I'm going to think about this as 3 separate division problems. Okay, and because it's a fraction, I often set up a fraction bar right away. So when I do my first division, 9 divided by 3, I can think of this as simply 9 divided by 3, or I can think of it as simplifying a fraction, like 3 goes into 3 once and 3 goes into 9 3 times. Sometimes this helps me keep my numbers straight so I know when a number goes in the numerator or in the denominator. Okay, now I'm looking at my m's. So I'm done with my coefficients. Now I'm going to just focus on my m's. If I have 3 on top and 1 on the bottom, and my rule that we just talked about a minute ago says that I have to subtract my exponents, that means I'm going to have 2 left over because 3 minus 1 is 2. Now, I have a decision to make. I will need to know if those m's are going to be in the numerator or in the denominator. Now, in this case, because there's more on top than there are in the bottom, I'm going to have my 2 m's, or my m squared, left in my numerator. All right, now I'm going to look at my n's. I have 5 n's on the top and 7 n's on the bottom. All right, ladies and gentlemen, what I'm going to need to do here is I'm going to need to look at this as a subtraction problem in a sense. So I have 5 on the top and 7 on the bottom. I have more in the denominator than I do in the top. So my 2 n's that I'm going to have left over are going to remain in the denominator. So my final answer is 3 m squared over n squared. And again, n is in the denominator because I have more n's in my denominator than I do have in my numerator. All right, let's look at the next problem here. So again, this is a fraction, so I'm going to set myself up right away with my fraction bar. And when I look at my 2 coefficients that I'm going to divide, I see that 12 doesn't divide without a decimal into 15. So I'm going to think of this problem right now as just 12 fifteenths, and I'm going to simplify that fraction. So to do that, I'm going to take out a common factor. So the common factor that goes into 12 and 15 is 3. So 3 goes into 12 4 times, and 3 goes into 15 5 times. So in my numerator, I'm going to have a 4, and in my denominator, I'm going to have a 5. All right, I've taken care of my coefficients. Now I have to look at my next common term, which is my h's. So I have 7 on the top and 2 on the bottom. When I subtract these, I know I'm going to get 5 h's. I have more on the top, again, than I do on the bottom, so the 5 h's are going to stay in my numerator. So I have h to the 5th on the top. I'm going to look at my j's. My j's are my next term. I have 8 on the top and 5 on the bottom. When I subtract, I know I'm going to have 3 left over. So I'm going to put my j to the power of 3 in my numerator. And again, I'm putting them in the numerator because I have more on the top than I do on the bottom. Okay, now I'm going to look at my denominator, or my k's, excuse me. I have k to the 9th divided by k to the 11th. When I subtract, I'm going to get k to the power of 2. But in this case, I'm going to put my 2 k's, or my k squared, on the bottom in my denominator because there's more k's in the denominator than there are in the numerator. So my final answers are going to look like this. So here's my answer for the second one. 4h to the 5th, j to the 3rd over 5k squared. And my answer to the first one was 3m squared over n squared. You've seen this slide before and you know what to do. Pause the video, talk with a partner about the quotient rule, jot down the quotient rule in your own words, making sure to include directions on how to calculate the coefficients and the exponents of the variables. For this rule, you might want to talk about how do you know if the variable is going to be in the numerator or the denominator of your quotient. All right, ladies and gentlemen, here are 5 practice problems. You need to do these on your own in your notebook. Show all your work. When your work is done, I need you to present your work to your teacher. Your teacher will check your answers and give you your homework if you've earned it. Do your best. Good luck. Don't forget that exponents are incredibly difficult rules to learn, know, and internalize. So you might make a few mistakes. You might make a lot of mistakes. Make sure you check in with your teacher and ask questions if you have them. Good luck.